Hello and welcome to PE and Everything. Today we're looking at the short-term effects of exercise, but before we go into that video, we need to look at the keywords surrounded around the short-term effects of exercise. So in this first clip, I'm just going to break down each individual word that I am circling for you now. Okay, so firstly we have got lactic acid, a waste product produced during anaerobic respiration, making the muscles feel tired during exercise. So if your muscles are fatigued, they need oxygen to remove this lactic acid and recovery. And the amount of oxygen needed is oxygen debt. So it's post-exercise oxygen consumption. Okay, so when you feel out of breath after a workout, this is your body's way of saying it needs more oxygen. Okay, now we just mentioned this word fatigue. Now it's the feeling of muscle soreness or tiredness after exercise or during exercise. Number 4, we have contraction. Now, muscles that tense cause movement. So as I've drawn here, the bicep flexing the elbow joint, causing movement. Okay, next we have heart rate. This is the number of times your heart beats per minute, and it's measured in BPM, beats per minute. Okay, so a normal adult's resting heart rate would be between 60 to 100 beats per minute. An athlete's resting heart rate can be up to 60, even 40 beats per minute. And how we calculate this is 220 minus our ages. Now here I've drawn a target heart rate zone. So between 40 to 60% would be resting heart rate, 60 to 80% would be aerobic, and 80 to 90 would be anaerobic. Moving on to blood pressure. This is how strongly the blood presses against the walls of the blood vessels. So this normally refers to the large arteries, and these are the aorta, the blood vessel that leaves the heart to supply oxygenated blood to the rest of the body and the working muscles, and then you have the pulmonary artery, which takes deoxygenated blood away from the heart towards the lungs. Next we have stroke volume. Now, stroke volume is the volume of blood pumped with each heartbeat by each of the ventricles in the heart. Now, in some cases, some people will take it as how much blood leaves the left ventricle. Okay, so that will be the going out of the aorta to supply the oxygenated blood to the rest of the body. Next, we have cardiac output. Now, the formula for this would be cardiac output equals heart rate times stroke volume, and this is normally defined as the volume of blood pumped by each ventricle in 1 minute. Okay, tidal volume, this is the amount of air that is breathed in and out of the lungs in one breath. It's a normal breath at rest, and the average amount of air to leave the lungs would be, they say, about 500 milliliters. Okay, that is perfect. And the fact that we've just learnt these terms, it means that we can go on to the next part and understand what we're actually discussing. Okay, this is the moment that everyone's been waiting for. Okay, and this is the criteria that we're talking about. So this is our body's response to short-term exercise, well, the short-term effects of exercise, and it responds to it in 3 separate ways. Okay, so we have lactic acid accumulation and muscle fatigue. Okay, the next one would be heart rate, stroke volume, and cardiac output. Now we know what these terms mean now, okay, so we're just breaking them down. The next one would be depth and rate of breathing. Perfect. Okay, so we're going to break down lactic acid accumulation and muscle fatigue. Okay, firstly, contraction of muscles occurs when any movement takes place. Okay, and when it does, the temperature of our muscles rises. So that means it creates heat. Okay, it creates heat. Your muscles work harder during exercise, so therefore more oxygen is required. Okay, we know that. Use oxygen, not O2. Okay, now the final one for this category would be if you cannot supply enough oxygen to your working muscles, you will accumulate lactic acid. And remember, the result of lactic acid would be being in the state, a fatigue state. So being tired, muscle soreness, okay? Okay, so we are moving on to the second category of short-term effects of exercise. And this is short-term effects of heart rate, stroke volume, and cardiac output. Now I'll put here, when you exercise, your heart rate increases, which means more oxygen is needed at the muscles. The next one would be your stroke volume increases, allowing more blood to be pumped around the body. Now, if we know that the stroke volume increases, if we know that the stroke volume increases, and we also know that blood pressure will increase, and we also know that heart rate's increased. So remember, if we times the two, heart rate and stroke volume, even though I put blood pressure here, it means that our cardiac output would also increase. Perfect. Okay, so the final one of this category would be if your body, so if you, when you're exercising, can't supply enough oxygen to that working muscle or muscles, your heart rate would remain high until oxygen debt is fully recovered. Okay, until it's fully recovered. So these are the key terms. Can't supply enough oxygen to the working muscle, heart rate will remain high, and then we have to wait for oxygen debt. What this shows is when lactic acid is accumulated in the working muscle, the only thing to remove it is oxygen. The amount of oxygen you need is oxygen debt. Excess post-exercise oxygen consumption. Finally, short-term effects of depth and rate of breathing. Firstly, your breathing rate increases as your body requires more oxygen. And as the picture will show, this dude needs more oxygen because he's working that hard. Is everyone understanding it so far? Yes, we understand it perfectly, sir. Cracking job. Moving on then. Okay, so the next one in this category would be the depth of your breathing would also increase, so therefore your tidal volume increases, meaning you can consume more oxygen per breath. Okay? And the final one in this category would be when you are working anaerobically, meaning you are exercising / working between 80 to 90% of your maximum heart rate. So, when you are exercising anaerobically until you consume enough oxygen to meet oxygen debt, your breathing rate and depth will remain high. Okay, so if you can just go over these things, it will help you to remember the short-term effects of exercise. Okay, so we're going to move straight into a question. So the question will be, what happens to your muscles if you do not receive enough oxygen during exercise? That's perfect. We've already talked about these things, so we can go straight into it. Okay? He's writing here. If your muscles do not receive the correct amount of oxygen, first point, when exercising, lactic acid will accumulate. And we know that. Anaerobic state, and if you get so far into your aerobic state, eventually your fatigue, which is a result of lactic acid will accumulate, which will result in your body being fatigued. That's perfect. We've discussed a great amount today in this lesson. So I want to thank you for watching and taking the time out to learn. Okay, that is perfect. Just a shout out here for anybody who wants to do some additional learning. Go and check out Planet PE because he's got a whole heap of stuff for you over there. Peace out.